So that's the next one. It also comes from Johnson and Cutnell, and it's also conservation of energy, but you need to do a drawing. So we have the water here. So the height, it says, is high tower. So that tower here, it's going to be 3 meters. So this is 3 meters. Okay, so this is the tower here. And it's not on scale. And then to her rest, so she's going to dive in the water and she's going to stop around here, right? So at 1.10 meters, um, the energy here, there is no more energy, there is no more kinetic energy left. So she's gonna speed up, there is no friction until she reaches the water, and then she's gonna slow down, and all that energy will be lost to heat, right? Because you have frictional force. So energy to begin with, so we go from point A to point B. So at point A, there is only potential energy. So that will be 67 times 10. And the height here will be the 3 plus the 110. So that will be 4.10. Okay, so that's the energy you begin with. But some of the energy, will be taken away. All the energy will be taken away by the friction. Okay? So friction is taking away all the energy. So at the end, there is no more kinetic energy. So that's going to be 0. And we suppose that here, potential energy equals to 0. So potential energy depends always on the reference. Okay, so the work done by friction will be equals to, so that will be the average force, so the force, times the displacement. So the work done by friction will be only over that distance here, because it's the friction due to water. So the work done by friction will be the force. So here we call that the average force. It's an average times the distance over which it's acting. Okay, so that was the only trick here. The only little challenge. Not much. Right? So the work done by the force will be about equals to. So you multiply, you divide by this, you get about something like 2500 Newton.